An exciting world of chemistry. I want to start by having you do these before you come to class. Have these balanced already, and then we'll go over these to start a class. All right, now, today we're looking at types of chemical reactions. You will not want to miss this class because I'm going to get to do some explosions. Yeah! All right, you'll laugh there. Types of chemical reactions. There are 5 types: synthesis, decomposition, single placement, double replacement, and combustion. So let's go through each of those. Synthesis. Synthesis is defined as a reaction where one compound is formed in the products. So in generic form, we're taking each element from one compound. There's a little link there. I'll show it to you in class. Need to save time right now. All right, so an example would be the formation of water. H2 plus O2 equals H2O, balancing up. We've done this before. Hydrogens are fine, oxygens are not, so we're going to put a 2 as a coefficient, and that makes it 2 for the hydrogens. So we balance it up like the following. All right, let's get rid of these. Okay, we'll do this one in class. Barium plus oxygen gives me barium, gives me whatever. We're going to find out. Okay, all right, so the second type, decomposition, is the reverse of synthesis. Whoop, back up. What we're going to do here is a reaction where one compound as a reactant, we're going to break it apart into its base elements or compounds. Now, there are 3 special decomposition reactions. You're going to have to study these and memorize these. I'm sorry. The first is metallic hydroxide, which forms a metal oxide plus water. So an example would be like iron 3 hydroxide forms iron 3 oxide plus water. We'll balance this in class. Metal carbonates, which form metal oxides plus carbon dioxide. Iron 2 carbonate forms iron 2 oxide plus carbon dioxide. We'll balance that one in class. And metal chlorates, which form metal chlorides plus oxygens. Example would be potassium chloride forms potassium chlorate forms potassium chloride plus oxygen. All right, we'll balance that one in class. Now, next, we have single replacement. Definition of single replacement. Reaction where one element and one compound form one element and one compound. There are 2 ways I can do this, either replacing the metal, replacing the nonmetal. We can't have nonmetals that go together. We have to replace them, and metal always goes with a nonmetal in that reaction. So let's look at the example. Copper to chloride plus aluminum. I'm going to show you this reaction in class. All right, so aluminum is going to act as my metal. It's going to replace the cation over here, the copper. So aluminum is going to go with chloride. Now, we got to remember oxidation numbers. So aluminum's plus 3, chloride's minus 1. So we cross them down, we get Cl, Cl3, and then we have what's left over. Copper gets kicked out as the guy who's by himself. Balancing it up, my aluminums and coppers are fine, but my chlorines are not. I've got 2 and 3. So I'll put a 3 in front of the copper 2 chloride and a 2 in front of the aluminum chloride. Now my aluminums are messed up, so I'll put a 2 in front of the aluminums, and my coppers are messed up, so I'll put a 3 in front of there, and it's balanced. We'll do this one in class, and I'll demonstrate this for you. Copper plus nitric acid, HNO3 yields. All right, so 4th type, double replacement. Double replacement is defined where 2 compounds form 2 compounds. Basically, the swinging single of the compound scene, we're going to flip partners here. All right, so this is a reaction I would have done in class, but the reaction decomposed, and I don't have it anymore. It's something called calcium carbide plus water forms acetylene plus calcium hydroxide. It used to be a really nice reaction, exploded, but it decomposed. I can't do it anymore. Balance it out. Calciums are good, carbons are good, hydrogen good, oxygens are not. So I'm going to put a 2 in front of that. Now I have 2, actually my hydrogens weren't good. So I had 4 and I had 2, so I put a 2 there, and my oxygens are balanced up from there. All right, we'll do this one in class, barium oxide plus aluminum fluoride. All right, last type, carbon dioxide combustion. Now, combustion is one that will mess people up. Reaction where a hydrocarbon reacts with oxygen to form carbon dioxide and water. Now, the reaction is some carbon-hydrogen combination plus oxygen forms carbon dioxide and water. You're going to look at this and you're going to go, okay, if I don't look at this side, I've got a compound and an element, it's going to be a single replacement. But the problem here is you would form carbon dioxide and hydrogen. And if we learn anything about hydrogen when it gets hot explodes. All right, so this is a reaction I can do for you in class. CH3OH methanol plus oxygen, that's a hydrocarbon. So we're going to generate carbon dioxide and water. My carbons are fine, my hydrogens are not. So I put a 2 there. Now I've got a strange problem. I've got 3 and I've got 4. Odds and evens, they'll never balance up. So we look, which one drives the reaction? That would be this methanol. That's where we got this 2 from. So we'll double it. When we double that, we have to double our other 2 values. So we end up with then 2 carbons, 8 hydrogens. Now, 4 plus 4, that's 8. I have 2 over here. 2 from 8 is 6. Put a 3 there. It balances up. All right. We'll do this one in class. Methane plus oxygen. This is what comes out of your Bunsen burners. All right. So I have 1, 2, 3, 4 reactions that I want to have you do with a partner in class, and then finish those reactions. Copy those down. We're done. Take care. Be good. Bye.